Hey guys, and welcome to week 3 of VBA. Now, this is the week where you really start seeing the benefits if you've done the past 2 weeks properly. So if you've done the past 2 weeks properly, you can really see that you should know how to calculate the average, and you should know how to calculate the standard deviation because it's exactly the same code as used last week in week 2. Okay, so for the first sheet, all you have to do is for the function, all you have to do is copy the code across and it'll work. But for the subroutine, all you have to do is modify your code in order to take these inputs. If you sort of don't know how to do that and you just want to take your function, which I demonstrated in a previous video, and adapt it to work with subroutines, refer to week 1b where we talk about converting a function into a subroutine. So I'll leave sheet 1 with you, and good luck, and we'll move on to sheet 2. Okay, so in sheet 2 here, what we have to do is count the number of rows and columns. Now, I've sort of done a cursory overview of this last week when we used sort of the name of the range dot rows dot count or dot columns dot count, but this week we'll be looking at it formally and sort of using code to be able to calculate the number of rows and columns. First of all, I'd also like to introduce a new trick which I think would be really useful for this unit going forward, and it's the fact that you can actually name certain groups of cells anything you want. Okay, so how about we start by naming this returns. So all you have to do is highlight the range, and then, well, it's already defined, but if it isn't, all you have to do is type returns here and press enter, and it'll name this range here returns. Now, it's going to be really handy when you go into VBA to have that named returns. Okay, so I'm going to open up the VBA development environment. Alt F11 is the trick, and we're going to go to sheet columns here, sheet 2. Okay, and now we're going to have to write a subroutine to calculate the number of rows and columns in this range. Now, what's really easy is we've named this returns, so we can refer to that very, very easily, and I'll show you how. So we've created a sub and named it count rows columns. You should know how to do that. I'm not going to go through that. And what we're going to do is we'll start with 2 outputs, one to C25 and one to C26. Okay, so we've created the line of code that is required to output to cell C25. You should know this code. Now, the code to calculate the number of rows is the name of the range dot rows dot count. Okay, now usually you'd be familiar with using range, and then you'd put some cells in there, right? But because we've named this returns, you can actually type in the name of the matrix, which is returns, and it'll know to refer to that. So by just typing returns in here, it's smart enough to know that it's referring to this entire range of cells here. Now, .rows.count will count the number of rows inside this array, okay? Now, for columns, it's the same thing, except you want .columns.count, okay? So if we write the code for that and output it to cell C26, you'll see that it's also very simple. Okay, now that we've got the code, we can run it and hopefully it'll work. And of course, we can see that we have 10 rows and 6 columns as required. Okay, now moving along, we can go to the next part, and here what we have to do is transpose stock returns. So the transpose of a matrix is you're changing the rows into the columns. So that might be a bit hard to understand, but let me demonstrate that graphically. Okay, so say we've got this matrix here, simple matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now basically, the transpose of a matrix turns the rows of one matrix into the columns of another matrix. Okay, so the first row here is 1, 2, 3, so that means that the first column of our resulting transpose matrix will be 1, 2, 3. Okay, see how the first row here has turned into the first column in this output transpose matrix, right? the second row becomes the second column. Yep, so as you can see here, the second row becomes the second column of our output transpose matrix. Now the third row will become the third column. So that's all a transpose is. You can think of it as sort of looking at it through a mirror, but the way that I like to see it, and I think the way that just makes a lot more sense, is that you're changing what are rows into columns, or you can also see it as you're changing what are columns into rows. So for example, originally we had 1, 4, 7 in the first column. Now the first row, no doubt, is 1, 4, 7. Okay, so you're just swapping around the rows and columns of the original matrix. So the rows become the columns and the columns become the rows. Now we can go back to our spreadsheet. Okay, going back to our spreadsheet here, what we have to do in here is calculate the transpose of this matrix. So we have to turn these columns into rows. Now, I'm going to do that via a function. So I'll show you the basics of the code and how it works, but you're going to have to do it via the subroutine. And if you're unsure how to do that, the best video to look at is week 1B. So we'll start as we always do by creating a module, as that's how we define a function. Okay, so we've created a new module and named our function transMatrix. And we know that our function transMatrix takes some particular input that's a range. That's this range right here when we put this range into the function, right? So it's going to take one particular range as input. Now the first thing that we need to do is, it's probably useful to know what are the number of rows and columns of our input, because that will be useful when we're defining our output, right? So let's define two variables which will count the number of rows and columns inside our input array. Now remember that the input here, I say array, but I say that very, very loosely. What I really mean is that it's a range, so it's really our input range, okay? So what you want to do here is you want to use the range.rows.count and range.columns.count in order to count the number of rows and columns exactly like you did here, but rather than outputting it to the spreadsheet, we'll be inputting them into these variables here. It's the same process. So you should know how to do that if you could do the previous part. Now what you have to do is think about what I guess transposing a matrix really means. So what transposing a matrix means is that you're taking the rows of each matrix and you're changing them into the columns of the subsequent matrix. We've just gone through that, okay? So you know that you need two for loops, one for loop to go across the row and one for loop to go down the column. So you're going to need a nested for loop. But before we get to that, it's good to have this idea in your mind. So right here, know that you're going to have to get to a nested for loop. But before you get to a nested for loop, think about, where am I going to output? So you know now that you need to define some sort of an output array. Okay, so we've dimensionalized an output array. Now we have to think about what are the rows and columns of this output array. Now the input array has no rows, and no columns, okay? So how does that translate to this? Well, if you're smart, you can look at this and you can see that it's just been flipped around, right? So it has the same number of columns as this number of rows, okay? Number of rows, number of columns. And it has the same number of rows as the number of columns here. So think about what we're doing. We're changing the rows to the columns. So this is across the row here is just going down the column. So going across the row is the number of columns, and going down the column here is the number of rows. So essentially we're changing the rows into columns and the columns into rows. Okay, so it's no longer going to be number of rows comma number of columns, it'll be the other way around. But remember that matrices start at 0, so we have to subtract 1 to ensure that our indices line up, okay? I should make a note that this input here is not a matrix, it's a range, and range.cell commands we know start from 1. So that's something that we've already established in the past. So let's redimensionalize our output array to have the right number of rows and columns. Okay, and we've done that. Now we're going to set up the structure of our nested for loop. We know that we're going to need to go across the row, and then we're going to need to go down each column. It doesn't matter which way you do them as long as you're consistent. Okay, so we've added in at this stage the structure of our for loop. So we're using I to loop across the rows, and we're using J to loop across the columns of the original matrix. Now we know that we're switching the rows and the columns around. So rather than using I, J to refer to the cells of the new matrix, we have to use J, I, because the rows have now become the columns and the columns have become the rows. Remember that arrays start counting from 0, so you have to -1 first. So we know that we're going to be putting into the output array j-1, I-1. So the jth row, the ith column, if that makes sense. And what's going in there is, of course, the input matrix, but I, j. Now, when we're inputting a range of cells, that actually inputs as a range, not as an array. So range counts start from 1, not from 0, like with arrays. So it's actually going to be INP, I, j. You don't subtract 1. Okay, now outputting from a function is very easy. You just have to set what you want to output. You just have to set what the... So outputting from a function is very easy. You just have to set the function name equal to what you want to output. And here we want to output the output array. So we set the function name transmatrix equals to output array. Okay, so we've set transmatrix is equal to output array. Now you don't have to put any indices or whatever inside it. That's all it takes, and that's what will work. Okay, now let's test our function and see if it works. So in order to call this function, you have to highlight the output cells that you want to use, and you call the function, and then you put in the inputs, and then now you close the brackets, and instead of hitting enter, you have to hit Control, Shift, and hold Control and Shift, and then press enter, because you're working with matrices now, not just single numbers. And cross your fingers and hope this works. And yep, that seems like it works. So you can see that the row here has become the column here. Okay, now let's move on. Okay, so moving on to the second task of this sheet, this is exactly the same as the first task. So once again, all you have to do is use this code, and it should work. So the beauty of functions is that you don't have to write it again. You don't need to write a separate function for this. All you have to do is use the function you've just written, and then just use this as input, and then there you go. That's the correct answer, transposing this matrix right here. Now with subroutines, in order to write subroutines from functions, I've gone through that in week 1B. So watch that in order to learn how to write the subroutines. Note that these two subroutines will be exactly the same, except the inputs and outputs will be different. So remember to modify your subroutine accordingly to account for the different inputs and outputs of these two problems. Now let's move on to the final sheet on matrix multiplication. Now we've gone through the code for matrix multiplication in the other video for this week, so week 3B. Okay, so now we're going to go through the basics of matrix multiplication and the code for it in the second video for this week, so week 3B. Now, using that, you should know how to do the first matrix multiplication, okay? And you should be able to get a correct result using exactly the same code as what we used in there, but of course modifying it so that it works appropriately with these inputs and outputs. Now I'm going to let you do this one by yourself because I think there is some challenge in doing that. Now with the second set of matrices here, it's going to require us to modify the code a little bit. So how about we go back to the code and look at how we can modify it such that it will work by any dimension of matrices. And this right here is the subroutine for the matrix multiplication. Now I'm going to show you how to write a function to multiply these two matrices here. Now remember that to write a function, all you need is I guess the meat of the subroutine, because if you go back to our diagram here, you can see that a function basically just takes the operation part of the subroutine and it handles the inputs and the outputs via Excel rather than via VBA code. So let's go through this code here and sort of have a look at what exactly we're doing. So if you look at this code here, you can clearly see that all of this stuff here is defining input arrays and importing input matrices into those arrays. We don't need that because all of this is going to be done by Excel, okay? So what we only really need in here is this middle part here, well I guess with the temp as well, because this is really where the magic happens and where sort of you really start to multiply the matrices. So let's copy this code and we'll try and modify it such that it'll work with this. So let's go back to, this is I think not week 2, this is week 3. Okay, so let's create a new module and we'll try and create this function here. So let's call this function matrix mult. And of course it's just going to take 2 inputs, and i.e. the first and the second matrix. Let's call them INP1 and INP2. Okay, so first of all, there are a few things that we need to change now, purely for 2 reasons. Firstly, we're now using input ranges rather than arrays, so that requires some modifications to the code. And secondly, we're also we're also working with no longer working with 2x2 matrices, so we have to find a way of modifying the code in order to suit that as well. So first of all, let's just leave this for now, and we'll try and calculate the number of rows and columns of input 1 and input 2. Now, if you don't remember from high school, in order for 2 matrices to be able to be multiplied, the number of columns of the first matrix has to equal the number of rows of the second matrix, okay? Number of columns of the first matrix has to equal the number of rows of the second matrix. So we only need to define 3 variables: the number of columns of the first matrix, the number of rows of the first matrix, and then the number of columns of the second matrix. And of course, the number of rows of 2 has to equal no_1, okay? Now that we've got that out of the way, what we're going to do is we're going to modify this loop such that it works with this. Now, the first thing that we need to change in here is that we have to recall that ranges begin from 1, not from 0, like arrays. So rather than saying for A is equal to 0 to 1 or whatever, it has to be for A is equal to 1 to whatever, and for B is equal to 1 to whatever, and for C is equal to 1 to whatever. Okay, but to what? Now that is sort of the really quintessential question that we want to answer. Okay, so first of all, remember what A is doing. So if you don't remember, go back to video 3b. But A is the variable that counts the rows of A. So for example, when A is equal to 1, we're working with this row. When A is equal to 2, we're working with this row, and so on and so forth. So essentially it's the variable or the count which is going down the rows of A. So we want to go from 1 to however many rows there are in A in total. Okay, so it will be from A equals 1 to no rows of 1, right? And now what does B go to? Well, B refers to the column of matrix B. Okay, so remember how we multiply matrices is we go across the row and down the column, 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 okay? And we do that with the different rows and columns, rows of A and columns of B. So the value B here is the column of B that we're up to. So say we start with this row here, we first have to multiply by this column, and then we multiply it by this column right here. So it's the number of columns of the second matrix. Okay, and now what is C? C is the element that we're multiplying. So say we're going across this row and down this column, we're taking this element by this element, this element by this element, and this element by this element. So 1 by 7, 2 by 9, and 3 by 11. So really it's going across the row or down the column, but they have to be the same, right? And it's realistically just the number of columns of A or the number of rows of B, but they have to be the same, right? So this is going to be no_1. And that's sort of the, I guess, the count or the inside count that we're going through. Now, this can all be the same. We can continue using the temp in order to aggregate across the rows and the columns, and it'll all be the same, except now, okay, so there's 2 things that we have to do here. Now, first of all, we realize that we haven't defined our output matrix yet. So let's define our output matrix. Notice that we can use integer types here because all of this code is will work with integer numbers only. Later on, we're going to modify this code such that it will work with double types. Okay, so now that we've defined output as an array, I should say, how are we going to know the number of rows and columns of the output? Now, I'm going to tell you that when you multiply matrices, the output matrix is going to have the same number of rows as A and the same number of columns as B. Okay, so if you want to think about it this way, the way I usually remember it is if you take, say, an n by m matrix and you multiply that by an m by k matrix, then the resulting matrix will be n by k. Okay, so you just basically take out the middle, the middle number, and of course these two things have to be the same because this refers to the number of columns of A, and this here refers to the number of rows of B, and they have to be the same. Okay, so this here is basically going to be a 2 by 2 matrix, but it's going to have the same number of rows as 1 and the same number of columns as 2. Okay, so we're going to redim that appropriately. Okay, so I'm not going to keep reminding you that with arrays you have to start from 0, so basically you have to subtract 1 because the number of rows and the number of columns obviously start counting from 1. This is a range, so by now I expect you to sort of remember that when you refer to a range you start from 1, but when you refer to an array you start from 0. Okay, so knowing that, we can move on. Okay, and also you have to modify the code. So remember before when we started from 0 and went to 1, here we're starting from 1 and going to number of rows in order to accommodate for the basically the input 1 and input 2 thing here. Okay, so basically we're going to have to change this to a minus 1 and b minus 1. Okay, and basically everything else can remain the same because it's still the same concept deep down. And of course, all we have to do now is output the output array back to the function, and you know how to do that because we've just done that in the previous sheet. Now I've just realized that we actually haven't input what no rows 1, no cols 1, and no cols 2 are, so we probably should do that before moving on. So let's just do that real quick. You should know how to do that from the previous sheet, but it's really just no rows 1 is equal to input 1 dot rows dot count. You should know how to use these commands by now. Okay, see, so it's always good to keep a lookout and remember that you've gotten everything in check before moving along. So now that we've gotten that in, let's move along and put the answers into here. Okay, so all we have to do is highlight these cells that we're going to be outputting into, and we have to type in equals, and then the name of our function, which is matrix mult, and then this is our input matrix 1, comma, input matrix 2. Now don't hit enter, but hold Control and Shift, and then hit enter, and you should get this answer right here. So I'll leave it up to you to check whether it's right. If it's not, well, I guess you can come to my class and laugh at me or something. I don't really mind. But okay, I really hope that it's right. Now, if you want to know how to modify this code to work with a subroutine, refer to video 1b. Okay, so that will show you how to just take this function and very easily convert it to the code required for a subroutine. And of course, for doing this first part of the question, watch video 3b, which goes through the basics of matrix multiplication. Okay, so it's been probably a bit of a long week, but this code and the code for the transpose is going to be really, really useful for next week onwards. So from next week onwards, there's barely any new programming at all if you've written these functions properly. So if you focus on writing these functions properly this week, next week all you have to do is copy these functions across and modify them slightly to work with the new variables and new data types, and it'll be very, very easy if you know how to do this. So this week is fundamental, so please, please, please do this correctly, and it'll make next week really, really easy. So I will talk to you then, and remember to submit this, and remember to put in your authkate and your name and all that good stuff. Otherwise you will get a 0, and I will talk to you next week. See ya.